Hello, and welcome to Backer Breaks It Down. In this episode, we continue to look at segments related to a circle, this time focusing on segments that are created by tangents and secants. So we previously explored this relationship, and what did we discover? Well, it's all stated in the Tangent-Secant Power Theorem. So if a tangent segment and a secant segment are drawn from an external point to a circle, then the square of the measure of the tangent segment is equal to the product of the measures of the entire secant segment and its external part. Or simply put, the tangent squared is equal to the whole secant times its external part. And even more simply put, check out that diagram. So the tangent is represented by A, and then the secant is made up of the two smaller segments of C and D. And if you add the two segments together, you get the whole secant. So C plus D is the whole secant, okay? So let's apply this relationship here because I have a tangent and a secant. All right, so the tangent is x. So I'm going to have x squared equals. And then I need the whole secant times its external part. Well, the whole secant would be 7 plus 9, and that's 16. So x squared is going to equal 16 times 9. And so I just need to do that math. And 16 times 9 is, I want to say, 144? Yeah, how about that? It is 144. So x squared is 144, which means x would be positive or negative 12, because algebraically there are two solutions. However, this being geometry, x is representing the length of a segment, so we're going to have to go with x is equal to 12. So that problem really wasn't all that bad. So let's check out another one, one that has algebra in it, okay? So following my secant tangent power theorem, I'm going to take the tangent squared. So in problem number 2 here, that's 16. And this is going to be equal to the entire secant. So x plus 16 plus x, that is 2x plus 16. So I'm going to have the 2x plus 16 times the external part, which is x. So I am going to need to expand this. All right. So obviously I'm going to have to do the 16 squared part. So that's 256. And then I need to distribute. So x times 2x is 2x squared. And x times 16 is 16x. And then because this is a quadratic equation, I have to get it equal to 0. So I'm going to subtract 256 from both sides. So I have 0 equals 2x squared plus 16x minus 256. And now I'm ready to factor. Okay, so remember, when you factor, the very first thing that you should do is you should look for and take out a common factor. Okay, so that's what I did here. I noticed that 2 was the common factor, so I took it out. I wrote down what was left over, which was x squared plus 8x minus 128, and then I factored that further. So I got 2 times the quantity x plus 16 times the quantity x minus 8. Algebraically, there are two solutions. The negative 16 doesn't make sense. 8 does. So that's the tangent-secant power theorem. Basically, the tangent segment squared is equal to the whole secant times its external part. And that's how Backer breaks it down.